Hi there, my name is Brian, and I'm going to give you a quick sort of unrehearsed demo of RL-Viz. So this is the interface. It'll be receiving some cosmetic work before the demo time at NIPS. Here we have a list of environments to choose from, like the grid world, helicopter, mountain car, Tetris, and a little sample problem we play with. As you can see, as you change which environment you want to work with, the set of parameters that control the specifics of that environment are automatically updated. Similarly, we have agents on the right-hand side here. We have one called Dinosaur that I've been working on. And then from the literature, we have generic Sarsa Lambda as well with its associated parameters. So we can literally just choose an agent like generic Sarsa Lambda, choose a problem like mountain car, hit load experiment, and press start, and we'll actually start to see the experiment unfolding in front of us. This bottom section screen here is the value function, which is why it doesn't make much sense right now. But at the top, you can see the hill if you're familiar with this problem. And there's the car on the hill, and it will go back and forth trying to reach this goal position. We can speed things up um, with this slider bar, or we can slow them down. Of course, we could stop and go one step at a time at our leisure. I'm going to speed this up quite a bit. Press start. And so you can see the value function sort of filling out here. We have, in worlds where we can easily do a visualization of the value function, we have this slider which allows us to either have it updating very, very quickly in real time, or we can trade off for a higher resolution picture, which will give us, it updates a little bit less frequently, but it gives us a prettier picture. If I put this slider all the way to the left side, we'll go into no delay mode, which will go super quickly. So I'm just going to do that now, just to get this value function sort of rounded out to the proper textbook mountain car value function, which is what you see here. If we wanted an agent to have a higher resolution picture of the world, we could go ahead and change some of these settings, like the number of grids, the number of tilings. Never mind for now what those mean. And then the agent will learn this value function, and if we crank up the resolution here, we can see that we have a very sort of fine picture of the world. This is actually what the agent's internal state representation looks at, like sort of. Alternatively, we can unload this experiment and go back to a very coarse representation, let's say 2 and 2, although I'm a little worried about that. And we'll load, and we'll press go, and it'll learn very fast. And then we'll see that it has this extremely coarse picture of the world. If I slow it down, it might become a little more clear here. So again, this is actually what the agent's, how the agent's representing the world now. As you can see, it's a little more coarse, and of course, he's having some trouble getting out. We can do other crazy things, like say, do we want random start states for the problem or not? What are the maximum and minimal values? The acceleration of the car. We do crazy things like make a crazy mountain car. Sort of whatever we want to do, we can just parameterize it and then play with it here. And of course, it's not all mountain car. We have a continuous grid world demo here. I'm just going to put these back to reasonable values instead of value of lambda, because that's always fun. So now we have this continuous grid world where we have an agent who's wandering around, and he's trying to get to this blue goal area, and the red area is borders. Of course, we can make whatever map we want here. This is just a very simple example. And so we can actually see exactly where the agent's going, what he's doing, what his value is, what he's learning. There's nothing particularly special about these agents or environments. Of course, if you want to visualize something, you have to write a visualizer. But the agents and environments are basically just standard RL glue agents and environments. I can make this go fast, and we can see the value function sort of fill out properly, and we can get an idea for what it really looks like. So that's fun. Unload that one and show you the Tetris world, which is kind of fun. Of course, again, with this parameterization, we can choose sort of any possible type of Tetris we want. Maybe we want to play square block Tetris that's 6 wide and 12 high, which looks kind of like this. Alternatively, maybe we want to go for broke, and we want to go for 12 wide, 24 high, full piece Tetris, in which case we'd see a picture more like this. Again, though, the point is you can stop, unload, change the parameters, press start, and you're good to go. We have some other environments that aren't in this video right now, and we have some cool things like the ability to load environments from Java or C++ as we go. but I think I'll stop talking for now, and that is, at a high level, some of the things that you can do with RL-Viz.